Alright, so picking up from video part 1, we can see that we're here on this estimating with exponential functions decay 1, that we came to 692 elephants. Now, the problems on this page continue to involve us writing our equation. Remember, with exponential decay, it's always 1 minus our decimal. But something to keep in mind is that on the back side, it takes away your template, right? It still asks you for your a value, right? So if we are going to be looking here at number 3 on part 2 of estimating with exponential decay, I would still go through similar process. I'd still find my a value here. So if we have a car that starts off at 23,000. All right, for the b value, it took away my template, but I still need to go through those same steps. I still need to do 1 minus that percent as a decimal. So that's why I did 1 minus 0.08 there to get that b value here of 0.92. So keep that in mind. Some people, once they get onto the back here, they're like, oh, I'm just going to write whatever my decimal is. We know it's always 1 minus that percent as a decimal. Alright, so here on our graphing exponential functions, what we can do is it already has pre-scaled graphs here for us. We'll be looking in. Now it says it kind of goes through some instructions here on how to double check with our calculator. And it also says to round to 1 decimal spot. But really all that's happening here is we'll be able to kind of figure out our different values here to fill out the table. Right, and so I'll kind of model us through this first one here. Right, so if I'm looking at this equation, it has a table. It's asking me for what my y-intercept is. Now I know that a value is always the first number we see listed. So my a value is 10. So on this particular one, my y-intercept is also that 10, and that's true for all of them. The y-intercept is always just our a value. But remember, we write our y-intercept as a coordinate point, where x is always 0. And then here my b value is 2. And this one's going to be growth because my b value is larger than 1. And we'd also be able to see that on, once we see the picture of our graph, we'll see that it starts slow and then increases quickly here. Alright, so what you can do here, if we don't have the calculator to help operate this by hand, right? So we already know this coordinate point, it's my y-intercept, it's 0, we can either plug in these different numbers in here for x, right? So to evaluate this one, I'm just plugging in 1 for x here. Sorry. So to find this answer here, it's just 10 times 2 to the first power, right? And when we do that, what this basically, another way you can think about this is the number we're multiplying by. It's our common ratio. You can also think about this as multiplying by 2 as each line goes on. All right, and you could also get this, so for example, this one right here, when x is 2, this would be 10 times 2 to the second power. And so 2 to the second power is 4. 4 times 10 gives me that 40. All right, so to find these, you can either plug in the -1. We haven't really had a chance to talk about negative exponents yet. That unit comes later. Or you can just follow the pattern backwards and see if I want to dividing by 2. So this -1 would be at a 5. And then the -2 would be at a 2.5. Right? Or you can go through the steps of just plugging in over and over again, or using your calculator to double check with the table. All right, and then we go and get these points plotted. So at -2, we're at 2.5. At -1, we are 5. At 0, for our y-intercept, we're at 10. At 1, we're at 20. 2, we're at 40. At 3, we're at 80. And then we'll be off the page. So we can continue this with a nice smooth curve here. Make sure we're drawing lines on the end. When I say lines on the ends, I mean arrows on the ends. But we can also see here that this is growth based upon the picture of the graph here. That's all this page is. Just going through, looking through the different ones. So for example, this one here, my It's going to be 0, comma, whatever my a value is. The b value is the number inside the parenthesis. Right, and I can either see this after the graph, or I could simply say, hey, my b value is smaller than 1, but bigger than 0. I know this has to be decay. And then we can fill out the graph by plugging in the different numbers for x here into our x to find this, or entering this equation into our calculator and using a table to complete those values there. And this one you're going to want to round to 1 decimal spot and do your best job to estimate here on the graph. If we wanted to use our calculator to do this, what we can do is it's this instruction. We would hit our y equals button. We get rid of our old equations, enter in the one that's for us. Be sure to raise it to the x there. And then once we hit second and graph, it'll take us to our table. And then we can scroll up and down and see the different values, rounding to 1 decimal spot. And right here we can see that y-intercept that we talked about in that initial page. So we'll be taking these values, putting them onto our table, and then getting it graphed.